Welcome to the sixth part of VCAA Specialist Math 2021 exam papers. In this video, we will present exam paper 2, section A, questions 11 to 15. More than half of the students did questions 11, 12, 14, and 15 relatively well. However, common error in question 13 was fail to use the unit vector of vector B.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Math exam paper series. This is section A of 2021 exam 2 paper. There are total 20 multiple choice questions in section A and 6 extended response questions in section B. In this video, we will present questions 11 to 15 in section A. In question 11, it says that a group of hikers travels 5 kilometers in the direction south 30 degrees west and then north for 10 kilometers. The question here is to find the position vector A of the group of hikers with respect to the starting point. As it can be seen from the diagram, they travel from the starting point O in the direction of south 30 degrees west for 5 kilometers to point A, and then travel from A in the north direction for 10 kilometers. Hence, accordingly, vector OA is written to -5 sine of 30 degrees I minus 5 cosine of 30 degrees J, which equals -5 over 2I minus 5 square root 3 over 2J, while vector AB is just a 10J. Hence, the position vector A equals vector OA plus vector AB, which equals -5 over 2I plus 10 minus 5 square root 3 over 2, all in parentheses J. So, the answer for question 11 is B. There are 3 vectors given in question 12. Vector A equals xi plus j, vector B equals I minus j, and vector C equals I plus xj. Here theta is the angle between vectors A and B, while phi is the angle between vectors B and C. The question here is to express cosine theta, cosine phi in terms of x. Since the angle between two vectors can be found by using the scalar product of two vectors, cosine theta is written to the scalar product of vectors A and B over the product of their modulus, which equals x minus 1, or over the square root of the result of 2 times the sum of x squared plus 1. Similarly, cosine phi equals 1 minus x, or over the square root of the result of 2 times the sum of 1 plus x squared. Hence, cosine theta cosine phi equals negative x minus 1, or in parentheses squared, over the result of 2 times the sum of x squared plus 1. Therefore, the answer for question 12 is D. In question 13, the scalar resolute of vector A in the direction of vector B is -4. The question is to find the vector resolute of A in the direction of B, given that vector B equals negative square root 3i. Since vector B equals negative square root 3i, its unit vector B hat equals -I. Because vector A dot product B hat equals -4, it follows that vector A equals -4 over B hat, which equals -4i. Hence, vector A dot product b hat, or in parentheses dot product b hat equals negative 4i times negative I times negative I, which equals 4i. So the answer for question 13 is E. Question 14 says that a body of mass 5 kilograms is acted on by a net force of magnitude F newtons. This force causes the body to move so that its velocity v meter per second along a straight line of motion is given by v equals 3 plus 2x, where x meters is the position of the body at time t seconds. The question here is to find the net force F when x equals 2. Since acceleration A equals the differentiation of velocity with respect to time, it also can be written to dv over dx multiplies dx over dt, which equals v times the differentiation of v with respect to x. According to Newton's second law, F equals ma, which can be written to mv times dv over dx, which equals 2m times 3 plus 2x, or in parentheses. Hence, f of 2 equals 2 times 5 times open bracket 3 plus 2 times 2 close bracket, which equals 70 Newton. Therefore, the answer for question 14 is D. The diagram in question 15 shows a stationary body being acted on by 4 forces whose magnitudes are in newtons. The force of magnitude F sub 1 newtons acts in the opposite direction to the force of magnitude 8 newtons. The question is to find the value of F sub 1. Since the body is in stationary status, the net force in both horizontal and vertical directions must be 0. Hence, we have 2 simultaneous equations established accordingly. In horizontal direction, we have F sub 2 times cosine 60 degrees plus 8 minus F sub 1 minus 6 times cosine 30 degrees equals 0. While in the vertical direction, the equation is F sub 2 times sine 60 degrees minus 6 times sine 30 degrees equals 0. Here we add labels 1 and 2 to the above equations respectively. Hence, from equation 2, F sub 2 can be calculated, which equals 2 square root 3. Then we substitute this value into equation 1 to calculate F sub 1, which equals 8 minus 2 square root 3. Therefore, the answer for question 15 is A.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.